Study Section 3. Measure of the center of a set of observations. Introduction. The primary aim of any investigator is to obtain a simple summary value, average, that can be used to describe all the observations in a set. Thus, an average is a single value that can represent all the observations in a distribution. The most representative value is one that is at the center of the distribution. They are otherwise referred to as measures of location or measures of central tendency. Learning outcomes for study section 3. When you have studied this session, you should be able to discuss the times. Take 2. Discuss the time measures of central tendency. Explain and calculate the mean. Explain and calculate median. Explain and calculate mode from a grouped data. Define and calculate the partition values. Discuss other measures of central tendency. Measures of central tendency. These are measures of the center of a distribution. They are single values that give a description of the data. They are also referred to as measures of central tendency. Some of them are arithmetic mean, mode, median, geometric mean, and harmonic mean. We shall discuss them one after the other. They are otherwise known as descriptive statistics. In-text question. Solution. The average age of the students is x bar is equal to 1 over n summation xi. The mean then gives 17.3, approximately 17 years 4 months. Calculation of mean from grouped data. We have seen in study section 2 that a large set of observations can be summarized into a frequency table which elicits some information about the data. This makes the computation of the mean from a grouped data very easy. The mean of a set of n observations of a discrete continuous variate grouped so that the value x1 take 2 so that the value xi is the center of intervals. I is equal to 1, 2 to k occurs with frequencies fi. Is mean is equal to summation fi xi over n. N is equal to summation fi. In a grouped frequency table for a continuous variate, xi's are the center of interval, that is, average of the upper and lower class boundary of a class otherwise known as class mark. Example 3.2. Given the frequency distribution of a random variable x as follows. Find the mean of the distribution. Solution. Find the class mark of a particular class by adding the lower and upper class boundaries of the class and divide by 2. N is equal to summation f. Mean is equal to summation fx over n is equal to 329 over 23 is equal to 14.304. Use of assumed mean. Sometimes large values of the variable are involved in the calculation of mean. In order to make our computation easier, we may assume one of the values as the mean. Then the revised formula for the mean is, if the assumed mean is a, then mean is equal to a plus summation d over n in bracket, where d is equal to x minus a. If a constant factor c is used, then mean is equal to a plus summation d over n in bracket times c. For a group data, mean is equal to a plus summation fd over summation f in bracket c, where u is equal to x minus a over c. The exact pension allowance paid in naira to 25 workers of a company is given in the table below. Calculate the mean using an assumed mean 35 and 5 as a common factor. Solution: let a is equal to 35, c is equal to 5. Mean is equal to 35 plus minus 9 over 25 in bracket 5 is equal to 33.20. Example 3.4. Consider the data in example 2.3 using the suitable assumed mean and constant factor. Compute the mean. A is equal to 15. C is equal to 10. Mean is equal to 15 plus 53 over 50 in bracket 10 is equal to 15 plus 10.6 is equal to 25.6. Note, it is always easier to select the class mark with the largest frequency as the assumed mean. Merits. The mean is an average that considers all the observations in the data set. It is simple and easy to compute, and it is the most widely used average. Demerits. Its value is greatly affected by the extremely too large or too small observation. Median. The median is an average of position. It is the value of the variable that divides a distribution into two equal parts when the values are arranged in order of magnitude. To compute the median of a distribution: 1. Arrange all observations in order of size from smallest to largest. 2. If n number of observation is odd, the median is the center of observation in the order list. The location of the median is x bar is equal to n plus 1 in bracket over 2 item. 3. If n is even, the median x bar is the average of the two middle observations is the order list. That is, x bar is equal to x n plus 1 over 2 in bracket plus x into bracket n over 2 plus 1 over 2. Example 3.5. N is even. The values of a random variable x are given as 11, 10, 13, 9, 13, 14, 16, and 20. Find the median. Solution: in an array 9, 10, 11, 13, 13, 14, 16, and 20, since n is even, median is equal to x bar is equal to x n over 2 in bracket plus x n over 2 plus 1 in bracket divided by 2 is equal to x4 plus x5 over 2. That is equal to 13 plus 13 over 2 is equal to 13. Example 3.6. N is odd. The values of a random variable x are given as 9, 7, 5, 20, 2, 12, and 1. Find the median. In an array 1, 2, 5, 7, 9, 12, 20, n is odd. Therefore, the median x bar is equal to x into bracket 7 plus 1 over 2 is equal to x fourth is equal to 7. Note, the occurrence of 7 in the above example is just a coincidence. It could have been any other value in the middle of the data set. Calculation of median from a grouped data. The formula for calculating the median from grouped data is defined as where LM is equal to lower limit of the median class, FM is equal to frequency of median class, N is equal to summation F is the total frequency, CFB is equal to cumulative frequency before the median class, W is equal to class weight. Example 3.7. The table below shows the length of 100 rods in inches produced in a factory. Take 2. Produced in a factory. Calculate the median. Solution. The first thing to do is to obtain the cumulative frequency distribution as follows. 1. Determine n over 2 is equal to 100 over 2 is equal to 50. Clearly, the median value belongs to the class 7 to 8. 2. The lower class boundary LM of the median class is 6.5. 3. Frequency of the median class FM is 38. 4. The cumulative frequency before the median class CFB is 35. 5. The class interval W is 2 and the median is obtained as is approximately 7.29 to 2 decimal places. Example 3.8. The following data represent the weight of product manufactured in a factory in kg. Calculate the median. Solution. First obtain the cumulative frequency distribution as in example 3.7. The following can be obtained from the above table as in example 3.7. N over 2 is equal to 125 over 2 is equal to 62.5. CFB is equal to 60. CFB is equal to 94.5. FM is equal to 25. W is 10. That is 104.5 to 94.5. Median is equal to 95.5. Merit. 1. It is easy to calculate. 2. It is easy to understand by many people. 3. Its value is not affected by extreme values, thus it is a resistant measure of central tendency. 4. It is a good measure of location in a skewed distribution. Demerit. 1. It does not take into consideration how the values of the variable. Mode. The mode is the value of the variable that occurs most often in a set of data. It is the most unstable measure of location. It is not a unique measure of location as the arithmetic mean. In some cases, it may not exist. Sometimes, when it exists, it is more than one, e.g., bimodal distribution. Let us see how the mode can be obtained from the discrete data. Example 3.9. Consider the data in example 3.5. The modal value is 13. Since it is the only value that occurred twice. Example 3.10. Consider the data in example 3.6. The mode does not exist. Example 3.11. From example 2, the mode is 2, that is, the value with the highest frequency. Calculation of mode from grouped data. The mode of a grouped distribution can be obtained either 1. From the frequency curve by finding the value at the highest point, or 2. By calculation using the following formula. From a grouped data, The mode is defined as where Lm is equal to lower limit of the modal class. Delta 1 is equal to difference between the frequency of the modal class and the class before it. Delta 2 is equal to difference between the frequency of the modal class and that above it. W is the class weight. Example 3.12. From the data in example 3.7, calculate mode. 1. The modal class is the one with the highest frequency, that is 7 to 8. 2. Lm is equal to 6.5. Delta 1 is equal to 38 minus 26 is equal to 12. Delta 2 is equal to 38 minus 19 is equal to 19. W is equal to 2. Therefore, mode is equal to 65 plus bracket 12 over 12 plus 19 bracket 2 is equal to 7.27. Example 3.13. Also consider the data in example 3.8. The mode is obtained as is equal to 91.02. Merit. 1. The mode is easily understood by many people. 2. It is easy to calculate. Demerit. 1. It is not a unique measure of location. 2. It presents a misleading picture of the distribution. 3. It does not take into account all the available data. 4. It is the most ideal measure of location when the distribution is highly skewed, e.g., distribution of wages of workers in a factory. Partition values. We have seen in section 3.2 that the median is an average that divides a distribution into two equal parts. So also, there is other quantity that divides a set of data in an array into different equal parts. Such data must have been arranged in order of magnitude. Some of the partition values are the quartile, deciles, and percentiles. Quartiles divide a set of data in an array into 4 equal parts. For simple series, first quartiles, Q1 is equal to X into bracket n over 4th item. Q2 is equal to X is equal to median is equal to X into bracket n over 2th item for simple series. Third quartiles, Q3 is equal to X into bracket 3n over 4th item. For grouped data, 1. First quartile, Q1 is equal to, for grouped data, where IQ1 is equal to lower limit of quartile 1, FQ1 is equal to frequency of the Q1 class, W1 is equal to width of Q1 class. Summation FQ1 is equal to CF below the Q1 class. 2. Third quartile, Q3 is equal to, where IQ3 is equal to lower limit of quartile 3 class, FQ3 is equal to frequency of the Q3 class. W3 is equal to width of Q3 class. Summation FQ3 is equal to CF below the Q3 class. Other measures of central tendency. Other measures of central tendency include the mid-range, harmonic mean, and geometric mean. Mid-range. The halfway between the smallest and the largest observation in a set of data is called the mid-range or range midpoint. It is obtained by adding the smallest and the largest together and dividing the result by 2. Example 3.14. Find the mid-range of the following data. Solution. Smallest observation 1. Largest observation 15. Mid-range is equal to 15 minus 1 over 2 is equal to 7. Example 3.15. Find the mid-range of the following data representing the number of children in 12 households in Agbowo area of Ibadan. Solution. Midrange is equal to 6 minus 0 over 2 is equal to 3. Usefulness. Information on midrange of temperature reading by meteorologists is used by visitors in the tourism industry. Limitations. It takes into account only the extreme observation. Geometric mean. Given observation x1, x2 to xn of a random variable x, the geometric mean, denoted by GM, defined as the nth root of the product of n observation in a set. That is, GM is equal to nth root x1, x2 to xn. Example 3.16. Find the geometric mean of the data in example 3.14. Solution. GM is equal to 7th root 1.5.7.15.12.9.7. 7th root of 396,900 is equal to 6.31. Example 3.17. Obtain the geometric mean of the data in example 3.14. Solution. GM is equal to 10th root of 4.1.0 to 5.1. GM is equal to 0, since 0 is one of the observation. Usefulness. Geometric mean is very useful in the computation of rates and indices, e.g., computation of price indices, etc. Limitation. 1. It cannot be calculated when the value 0 is one of the observation to be used. 2. It is a readily used measure of location. Harmonic mean. Given the observation x1, x2 to xn of a random variable x, the harmonic mean, denoted by hm, is defined as the reciprocal of the mean of the reciprocal of the observations. That is, example 3.18. Find the harmonic mean of the data in example 3.14. Solution. hm is equal to 1 over 7 into brackets 1 over 1 plus 1 over 5 plus 1 over 7 plus 1 over 15 plus 1 over 12 plus 1 over 9 plus 1 over 7 is equal to 4.02. Find the harmonic mean of the data in example 3.14. Solution is equal to 0, since 0 is one of the observation. Note, hm is less than gm is less than am. Usefulness. Harmonic mean is used in the calculation of rates, e.g., average speed. Limitations. 1. It is hardly used in practice. 2. It cannot be calculated when 0 is one of the observation in the set. Other partition values from grouped data. The other partition values that can be calculated from group data are the deciles and the percentiles. Deciles are those values that divide a distribution to 5 equal parts. They are denoted by di. I is equal to 1, 2 to 9. D1, D2, D3 to D9. For the grouped data, deciles 2, D2 is defined as where LD2 is equal to lower limit of decile 2 class, LD2 is equal to frequency of the decile 2 class, W2 is equal to width of decile 1 class. Summation F D1 is equal to cumulative frequency below the decile 2 class. Percentiles are those values that divide a distribution into 100 equal parts. They are denoted by P1, P2, P3 to P99. For a grouped distribution, the 65th percentile is defined as where LP65 is equal to lower limit of 65th percentile class. FP65 is equal to frequency of the 65th percentile class. W1 is equal to width of 65th percentile class. Summation FP65 is equal to cumulative frequency below the 65th percentile class. Example 3.20. Consider the data in example 3.9. Calculate the 1. First quartile Q1, 2. Third quartile Q3, 3. Fourth decile D4, 4. 45th percentile P45. Solution from the table in example 3.9. 1 is equal to 85.79. 2. 108.67. 3. 111.64. 4. 93.36. Summary. In study section 3, you have learned that 1. Measures of central tendency are single values that give a description of the data. 2. The arithmetic mean is the average of a set of observation is the sum of the observation divided by the number of observation. 3. The mean is an average that considers all the observations in the data set. 4. The median is an average of position. 5. Median is a good measure of location in a skewed distribution. 6. The mode is the value of the variable that occurs most often in a set of data. 7. The mode is not a unique measure of location. 8. The partition values are the quartile, deciles, and percentiles. This is the end of study section 3. Thanks for listening.